Hello, students. Good day. How are you? I want to start our lesson now. The topic is phenomena supporting kinetic theory. Our learning objective, that is, after this lesson, what we will be able to do is that, number one, we should be able to explain Brownian motion, also explain diffusion, also explain osmosis. Now I want to start the introduction. The particles of matter are so tiny that they cannot be really seen, but the exact speed, that is the velocity, and the position of the particle can be detected. So some phenomena have been able to support the kinetic theory of matter. These phenomena include Brownian motion, diffusion, and osmosis, and others. But we limit ourselves to these three: Brownian motion, diffusion, and osmosis. We want to take them one by one now. Brownian motion. In 1827, a botanist, Robert Brown, observed a haphazard, that is the zigzag movement, when some polygrains were suspended in water. On further study using an electron microscope, it was observed that this zigzag movement of the polygrain was as a result of the bombardment of the polygrains by the molecules of the water. So this movement of water molecule is called Brownian motion. This is named after the man who discovered it. Such movement or motion can also be discovered with smoke particles when light passes through them. Now, I want to talk about diffusion. Diffusion occurs when there is a difference or change in the concentration of two substances. Diffusion can be defined as the movement of solute particles from a region of higher concentration to another region of lower concentration through a medium. And the diffusion occurs in gases. It occurs also in liquid and solid at different rates. You can see these two diagrams. The one with a particles, just put it, before you know it, from within a short time, the whole particle will cover the whole liquid. That's an example of diffusion. So we have diffusion in gas. So the particles in a gas are very far apart and they move at very high speeds. At a rate of diffusion, the rate of diffusion in the gas could occur in varying perfume and insecticides. So diffusion in liquid also is slower than in gases. This is because the particles of liquid have less average kinetic energy, and force of attraction tend to keep the particles a bit together. So diffusion in liquid could occur when potassium manganate 4 or potassium permanganate and copper 2 sulfate are added to water respectively. What of diffusion in solid? Diffusion can also occur in solid, but this takes place after a long time. For example, when a bars of gold and silver are brought together after many years, some particles of gold will have diffused into silver bar, vice versa. So these are just the rates of diffusion in liquid, solid, and in gas. Now, osmosis. Osmosis is a kind of diffusion, but in this case, water molecules, instead of solute particles, have to move. It requires a semi-permeable membrane to occur. Therefore, osmosis is the movement of water molecules from a region of higher concentration to a region of lower concentration through a semi-permeable membrane. Cells get most of their water by osmosis. So that's the phenomena, the 3 phenomena that support kinetic energy. Now, our oral questions just is for us to we know what we have learned. What is diffusion? Then explain diffusion in solid, in liquid, and in gas. So you have seen that the different type of diffusion. Diffusion is very, very fast in gas, minimal in liquid, but very, very slow in solid. So our assignment is explain osmosis. And number 2, what is Brownian motion? Thank you very much. God bless you.